Hello guys, welcome back. This is Krishna again and welcome to AI Martian. Today we will talk about in deep learning series about TensorFlow reshaping method. Okay, so let's go through the Google Colab sheet and we will go through each code individually and I will let you know like what kind of working of those operations. So let's move to Google Colab sheet, guys. So guys, in this sequence, we will talk about reshape and then its basic reshape, flatten a tensor kind of stuff. So let's copy this very first heading, okay? And I already import TensorFlow because I will do all operation using TensorFlow only. So let me make a heading of this. All right. So I have to create, first of all, a tensor. So let's create a tensor. Tensor is tf dot variable. I will create a very simple tensor which contain 8 element inside it. Okay. And I will print this value and I will get one dimension tensor. See, it has 8 element and dimension is 1 because inside this tuple we are getting one element only, and that's why we are getting one dimension tensor. Okay, and its data type is int32. I already thought about it. Okay, so let's create the very first basic reshaping. What is basic reshape? So I want to convert this tensor into 2D array. So how can I convert it into 2D array? So if I will convert this in 2D array, I have to simply reshape it. And in reshaping, what happened? First of all, we have to always care about one policy. The policy is we never insert new value inside it, and we cannot remove any value from this. Okay, we have to use every element to create a new tensor with new dimension, with a new dimension. That is called reshaping. Okay, so see, if I want to use this tensor, okay, to create a two-dimension tensor, right now it is in one dimension, but I want to convert it into two dimension. How can I do this? So first of all, we should have a good understanding like one dimension, two dimension, which I already taught you in this playlist. So I would request you to start watching my playlist from start, so you will able to understand each and every topic properly. Okay, so see, I want to convert this tensor into, let's say, in a shape of 2 comma 4 or 2 cross 4. Okay, the shape should be 2 cross 4. That means 2 row and 4 column. Okay, so how can I create it? So first of all, I have to create one vector. So 1 2 3 4. Okay, the first vector contain 4 elements and the second vector will contain remaining element 5 6 7 8. Now I have to close it inside a bracket because we do not have big brackets, so we are using small bracket. Similarly, TensorFlow also do the same. Okay, it also use small bracket like this. Okay, so this tensor have 2 row, okay, and 4 columns. This is column and this is row. Okay, so I will reshape this tensor and I will use all elements. See, I use every element 1 2 3 4 5 6 7 8. I did not drop any element. I did not append any element. I did not add any element. Okay, so how can we do it coding wise? Okay, so let's see. I will use tf dot reshape. I will pass that tensor A and I will say shape is equal to 2 comma 4, and I will store it inside a variable called result. When I will print this result, I will get the same output what I have to show you here. Okay, 1 2 3 4. Okay, so it will look like this 1 2 3 4. Okay, see, 1, 2, 3, 4, and then 5, 6, 7, 8. 5, 6, 7. Okay, and it is closed inside a big bracket, we can say, because in if we are not in mathematics sheet, right? We are in Google Colab sheet. So Google Colab or a Tensor or NumPy or Array, everybody use like this small bracket one. Okay, so this is my two-dimension array. Okay, so this is how we reshape our two-dimension array. Now this reshaped array stored it inside result. So if somebody will ask you, can you convert it back to this kind of array? I will say yes, I can convert it back to one dimension array. But how? So I have to use reshape method again, but there I have to pass a parameter. So what parameter I have to pass? Let me clean the window and see. Here I will use tf dot reshape, and I will pass result this time, because inside result only we have this two-dimension array. See, the shape is 2, 4. Okay, so it is two-dimension array. So I will pass result, and here I will pass shape is equal to -1 comma. If I will do this, I will get in one dimension array. So I am storing it in a variable called flatten. Okay, because I'm flattening it, I'm converting it into one dimension array. So whenever you convert any kind of matrix or tensor into one dimension array called flatten. Okay, so I will print this flatten, and see, we will get back the same tensor 1, 2, 3, 4, 5, 6, 7, 8, and its shape is also, that is 8 element but one dimension, because inside this shape we have one value, okay, that is 8, which is simply indicating the number of element inside this tensor. Okay, and this tensor is 1D. You can see it here, the bracket, and you can also get the idea from this place, like inside this tuple you are getting only one element inside. So this is, that means we have only one dimension array. So these two topic I just covered. Okay, you can flatten n number of dimension into single vector or array. Okay, one dimension array. So this is our first topic. Now we'll talk about this expand dimension. What is expand dimension? Let me make a heading of this. Okay, so expand dimension means, as we can see the name, expand means to enhance the dimension of an array or or a matrix or a tensor. Okay, means we increase the dimension. Suppose it is 2 dimension, I will make it 3 dimension. Suppose it is 1 dimension, I will make it 2 dimension. So if I am enhancing dimension size, in that case, expand dim come in picture. Okay, so tf dot expand dim we use. So I'm going to take one example here. Again, the same example, I will use tf variable, which will contain 8 elements. Okay, why I'm taking similar example? Because I don't want to make you confused, so you guys will get idea like what kind of array we have and what we are doing. Okay, that's why I'm using same array. So now I want to convert this into multiple dimensions. Okay, so in expanding, there are three ways. Okay, first, if I want to expand the dimension of this given matrix or array, I can do that. How? Using reshape. So first of all, tf dot reshape, I will pass this tensor a inside it, and I will pass shape. Let's say I want to convert it into 2 row and 4 column. So 2 row and 4 column means there will be 2 row like this, and it will enclose inside another bracket. So 1 comma 2 comma 3 comma 4, this is first row. 5 comma 6 comma 7 comma 8, second row. So this is called the shape of 2 comma 4, which I have mentioned here. Okay, so if I will run this, I will get this particular tensor into form of this. Okay, so let's create this. Okay, so how can we create this? Let's see. If I will simply run this, let's say I'm storing it inside a variable called result, and I'm printing this result, I will get this kind of output. So see, I'm getting first row having 1, 2, 3, 4, and second row having 5, 6, 7, 8 element inside it. And it is enclosed inside another bracket. And that's it. That is why this is called two dimension, because at the start we have to bracket. Okay. So similarly, if you want to get idea from this shape parenthesis, you can see there are two elements. That means two dimension array. Okay. If there will be one element, that means one dimension. Okay. So this is how we convert a one dimension array to two dimension array. And one more thing, keep in mind, never try to get new element inside it, because reshape does not support new element inside it. So always try to put those values which will be in the form of the multiple of this number of elements. Suppose here we have 8 number of elements. Okay. So just try to get multiple of this value, like 2 cross 4 is equal to 8, 4 cross 2 is equal to 8. Okay. 1 cross 8 is equal to 8. 8 cross 1 is equal to 8. But except these combination, we do not have any combination of values which will get multiplied and give us such kind of output for two dimensions. Okay. So keep this thing in mind. All right. So let's move further and talk about it. We can also expand the dimension using expand dims. There is a functionality called expand dims. This expand dims allow us to enhance the dimension row wise and column wise separate. Okay, how can we do this? Let's see. So expand dim support two things. First one is axis is equal to 0, means column wise higher dimension, and second one is axis is equal to 1, means row wise higher dimension values we can create, or tensor we can create. So these two operation it handle. Okay, expanding. So how can we use it? So let's say I have a tensor which is this only stored inside a variable called result. So I am using here a result. Okay, just to get the idea, I'm printing it. So I will always keep in mind like what kind of array look like, okay, on which I'm going to perform such operation. So right now I'm going to expand the dimension of a row. So here I have to mention axis is equal to 1. Okay, but how can I do this? So tf dot expand dims, I have to pass. Here I have to pass the tensor, which is result in my case. Okay. And I have to pass here axis is equal to 1. Okay. If I will do this, I will get such kind of output. Let me show you. Our tensor look like this. 1, 2, 3, 4. Okay. 5, 6, 7, 8. And it is inside a bracket. But if you will implement this one, it will simply enhance the dimension of a row. Okay. So what will happen? It will simply add one more bracket from both the rows. Okay. So it will become now 3 dimensions. See the number of bracket at the outermost or starting point. We have 3 square bracket, 1, 2, and 3 square bracket there. So that means this is 3-dimension array or matrix. Okay. So let me run this and we will get the same output. I just want to show you. Okay. So for now, I'm running it. Okay. But let me store it in result 2. Okay. Result 2. Let's see. So now, initially, my dimension looks something like this. See, the shape was 2, 4. But now my dimension look like this. My matrix look like this, and its shape is also having three element, means it is three dimension. So the first one is column. So each row have four columns. See, one, two, three, four, four columns. If you will create row, so row like this, okay, row arrow, so it will indicate each row. This is first row, this is second row, this is third row, this is fourth. So the first value of this shape is showing us row, and this is showing us column. So this is our 2D array. Inside this 2D array, we have only one 1D array. Okay, that is why in this 2D array, we have 1D array. That means there is only one row. Okay, that is why here we have one. But this two-dimension array, we are getting two times. Okay, so this is first time and this is second time we are getting. Okay, so that is why this is mentioned here. Okay, so these 2D array basically we are getting two times. Okay, two-dimension array we are getting two times, and that is why here it is mentioned two. If here it is mentioned three, we get such kind of one more dimension like this. And here we have some random value, let's say 8, 9, 10, 11, some sort of values. Okay, so it will be 3 now. If something, some such kind of answer we will get, then only it will turn to 3. Okay, so hope you guys understand this. All right, let's move ahead. If you guys don't understand, don't get panic, okay, because we didn't start a deep learning series so far. Okay, we are not training model. There these things are quite simple. Okay, but because TensorFlow functionalities are there, I have to tell you like what kind of functionality we can use. All right, so moving ahead, we can also perform the same higher dimension kind of operation row column wise. Right now we just did it row wise because I use axis 1, so this is simply indicate row wise operation. Okay, but now I want to do column wise operation, so I have to keep axis 0 here. Okay, and it is column wise higher dimension, we can say higher dimension, we can say. Okay, so how can we do this? So again, I'm using result. Okay, result is a tensor which we create using reshape in the form of 2 cross 4. So this is our tensor. Okay, I want to convert it into a higher dimension, but column wise this time. Okay, so how can we do this column wise? So it is very simple. Let's see. tf dot expand tims, and I have to pass result here, and axis will be 0 this time. Okay, and I will store it inside result 3. Result 3. If I will print this value, result 3, so we will get some sort of answer. I will show you 1 second. Let me clean the window. So again, our matrix look like this. This result look like this. Okay, so let me draw this 1, 2, 3, 4. Okay, the other one is 5, 6, 7, 8. This is our matrix. Okay, which is in the form of 2D. But now I want to make it higher dimension according to its column wise. Okay, so there are like how many columns? 1 column, 2 column, 3 column, and 4 column. Okay, so throughout this tensor we have 1 column, 2 column, 3 column, 4 column. So in this case, what will happen? The tensor will assign square bracket just at the end. See, just at the end. Okay, initially it was, means according to row wise, it was like in each row there was one bracket get attached. Okay, but in column wise it is not like that. You have to simply you can simply see the changes. Okay, here we are getting this square bracket in each row, but here we are getting at the end. See, at the start and at the end. Okay, so this is called row wise higher dimension. Okay, so how can we perform this? Let me clean this. Okay. And let's print it. So we will get the same output what I have drawn here. Okay. So see, we are getting 3 bracket initially and 3 bracket at the end. There is nothing like we are getting here also some sort of bracket. 1 second. We are not getting here any kind of bracket like the initial one. Okay. So this is, we are actually converting it into column wise higher dimension. Higher dimension. It is column wise higher dimension. That is why we mentioned axis is equal to 0. So I know this is quite complicated. You guys have to practice a lot, because without practice, nothing is impossible, right? But as the word said, I am possible itself. So definitely, if you do practice harder, you will definitely get a understand this, and you will definitely able to think about it also, like how the tensor look like, how can you assume tensor in your brain, so you can do much complicated operations of machine learning, deep learning. Okay, because if your conceptual power will become higher, then only you will able to think out of the box, and you can solve any kind of a problem which is uh, very much demanding in industry in the field of AI machine learning. Okay, because the person who have a lot of experience, who have higher visualization capacity, can only get hired at very good position in the industries. Okay, so you have to keep this thing in mind. Initially, it is tough. Of course, it is tough. That's why people are getting a higher package in this field, right? So this is all related to kind of money. Okay, so you guys have to be more familiar with the money. Okay, and you should like money also. All right, anyways, move further. We will move to the next topic, which is squeeze. Okay, these all operations available in NumPy also. If you will go through my NumPy playlist, this is there also. Okay, so let me create one more heading. Okay, so yeah. So as you can see, squeeze means remove dimension. Right away, we were enhancing the dimension. We were adding the dimension. We were making it higher dimension kind of matrix. But now we have to reduce it. Okay. So how can we reduce it? So let's think about it. This is result 3, right? This is result 3. Let me print it here. Okay. This is result 3. Print it here. Okay. So you will get 3 brackets. 3 brackets where? At the start. Okay. 3 bracket at the start. Okay. So if you will use squeeze operation on this tensor, it will simply give you a kind of array or matrix which looks something like this. Which will look something like this. Means what happened? Means it thinks something like that. Suppose we have a square bracket, but this square bracket, if I will remove, my number will not get changed. Okay. So in that case, squeeze will remove such kind of square bracket, but that square bracket should be in pair. Okay, means this is the open square bracket and this is their closed square bracket. So if the dimension, if the squeeze will remove this square bracket, then this square bracket will get removed, not this one. Okay, so this works something like that. Okay, let's perform this operation on the same result matrix. Let's perform the operation tf dot squeeze, and I will pass result 3. It will simply remove my square bracket which is there, additional square bracket. This square bracket it will remove. So its dimension also get reduced, right? So it will turn into 2 dimension. Means inside this shape we will get only 2 elements, not 3. Right now we are getting 3 elements. So see, I am running this shell now, and what will happen I will show. So see, we are getting square bracket, then one more square bracket, and in that square bracket we are getting 4 elements. So it simply remove 1 dimension from here and it is giving you an output. Okay, so it is called reducing the dimension. Means we read about expanding the dimension, expand dims, right? Initially we read about expand dim, but now right now we are reading about squeeze, like reduce dim or dimensions. Okay, so this is how it works. Okay, and let's move to the last concept. So last concept is transpose. Transpose in your school days mathematics book in matrix chapter. Okay, so transpose is something like this. In a school, how we were doing, let's see. So we have a matrix. Okay, let's say 1 2 3 4 5 6. Its shape is 3 row and 2 columns, right? It is stored inside A. Okay, now my teacher asked me, Krishna, convert this matrix or transpose this matrix. What you have to do? Transpose the matrix. Okay, this matrix. Okay, I said, okay sir, let me transpose it. What I simply did, let me tell you. So I simply do what? I mention 1 3 5 2 4 6. I said, so now we have 2 rows and 3 columns. So this is transpose operation only. Okay, so let's perform the same with this. So now I'm going to use the same demonstration here. Okay, so I'm using transpose. Okay, let me make a heading of this, and tf dot variable I'm going to use, and I'm creating the very first matrix A. Okay, which is mentioned here. So we have 3 rows, right? So how can we do this? So we have to create a 3 brackets like this, separated by comma. Okay, and inside each bracket I have to pass 2 values, like 1 2, the very first value. Okay, then 3 comma 4, then 5 comma 6, right? This is the same value mentioned here, and this is inside a big bracket. This is the big bracket in the outermost. Okay, see. So this is that tensor, okay, which my teacher gave me and asked me to transpose. So see, it is looking like this now. 1 2 3 4 5 6. 1 2 3 4 5 6. Okay, now my teacher asked me to transpose this. I said, okay, so let me do it. tf dot transposed I use. See, transpose I use. I simply have to pass that a tensor inside it, and I stored it inside a result because my teacher asked me for result, right? So I also assigned it to a variable called result, and I press shift enter. What did I get? 1 3 5. The very first column become very first row. See, and the second column become second row. Now you guys will ask me, what is the importance of this? So I told you, if you heard about if you still remember about matrix chapter, okay, definitely you guys will understand what is the use of it. But anyways, I will tell you. So let me give you one example on this. Okay, so let's think about it. When I was performing matmal operation, matrix multiplication operation, matmal, matrix multiplication. If you have gone through my playlist, you would get it. Otherwise, you would not get it. So that's why I always recommend you to go through the playlist from the start. Okay, don't do wildcard and drain this. Otherwise, it will definitely create some problem, because I will use most of the time such kind of terminology which I already have taught you in the past videos. So that's why I recommend you to go through my playlist from the start. Okay. So what is matmal? Matrix multiplication. In our school, my teacher gave me a matrix. He said, Krishna, this is a matrix, okay, of shape 2 cross 2. Okay. And he gave me one more matrix. He gave me one more matrix. He said 3 2 1 1 4 4. Okay, its shape is 3 cross 2. My teacher asked me, Krishna, can you multiply this A tensor to B tensor? I said, no. But why? Why did I say no? Because I know about matrix. I had good knowledge on matrix, okay, at that moment also. So is there any kind of logic there? I said yes. So have you thought about it? I said yes. I thought about it in past videos. Please go through it. But anyways, I am telling you one more time, okay? So this is what? This is my column and this is my row. Similarly, this is my column and this is my row. First policy, first policy, or you can say rule, we have to keep in mind. If you want to do multiplication between two matrix, the first matrix column should be equal to second matrix row. But this time, 2 is not equal to 3. And that is why I said, no, it is not possible. My teacher asked me, Krishna, can you multiply it anyhow? I said, yes, I can multiply it, but I have to do some transformation. So what kind of transformation? I have to calculate transpose, transpose of this matrix. Why of this matrix only? I said, because here I'm getting 3. If anyhow I will get this 2 on row and this 3 on column, I will get some sort of dimension where this rule is fulfilled. The first matrix column equal to second matrix row. Okay. So how can you do this, Krishna? My teacher again asked me. I said, okay, let me calculate the transpose of B, sir. Okay. So I calculated the transpose of B. So I use first column, okay, as a row here, 3, 1, 4. And second column I used as second row, 2, 1, 4. Now what is the shape? So row, there are 2 row and 3 column. So my shape is 2 comma 3. Now this is the shape of B and the shape of A was 2 comma 2 or 2 cross 2, you can say. You can also use cross, okay? So the policy I just introduced is the column of, this is column, this is row, this is column, this is row. The column of first matrix equal to the row of second matrix. So this C is equal to R, okay? So C is what? 2. Here we have 2. And R means what? We have 2, okay? So this is equal. Now multiplication is possible. Now matrix multiplication is possible. Mat mul is possible. Okay. So that is why people introduce transpose, and that's why we are performing this operation transpose. Now you guys will ask me, Krishna, why didn't you give us some such kind of demonstration on these? Because I know there are a lot of demonstration in future on such kind of thing. That's why I didn't give. But transpose use very minimal throughout the course. That's why I'm giving you a demonstration on this. Anyways, let me create the same, okay? I'm just creating the same A and B kind of tensor, okay? So how can I do this? Let me scroll it up and let me clean the screen also. It is looking very dirty now. Okay, this is fair enough. I can work with this. So I'm giving you one example on transpose. So I'm creating first tensor. A is equal to tf dot variable. And this is my first tensor. 2 comma 2. And then one more bracket. And here I will mention 3 comma 3. I know you guys will get irritated by this board, but this is kind of suggestion we always get everywhere. In VS Code also you will get it. So these actually suggestions help us out to understand what we have to pass next, because we are a kind of mathematician, okay? We do not memorize the thing. We use our logic and we implement the most suitable option. Okay, and that's why such kind of suggestion we require most of the time, and that's why it is appearing on the screen. Okay, so this is good, not bad. So don't get irritated, all right? So print A, if you will run this, you will get the very first, this one, 233. Okay, 2233 array. Okay, so you will get this this matrix, 2233 matrix, A matrix. Okay, now I'm creating B matrix. So B matrix contain 321144. Okay, so let me create it, tf dot variable, and there are three rows. So I'm creating three square bracket inside a big bracket. Okay, so the outermost bracket I'm saying big bracket, but that is not big. Okay, we can see that, right? So 3 comma 2, and this is what, 1 comma 1 I have to pass, and this is 4 comma 4. All right. So now if you will print this B, you will get such kind of matrix. So this is similarly look like this. So if you will ask me, Krishna, can we multiply this A to B? I will say, let's try. If you guys have forget, then only I will ask, let's try. tf dot matmul. Oh, let me remove this. tf dot matmul. So matmul is there. I have to pass two matrix, because whenever we pass two matrix, then multiplication is possible only, because we are doing matrix multiplication. So minimum two matrices are required there, right? And that's why I have to pass two matrices there. So if I will run this, I'm getting some sort of dimension issue. Why? Because I just told you the shape of the first matrix is 2 comma 2, and the shape of second matrix is 3 comma 2. So tell me, is it is it applicable? Is it the column of first matrix is equal to row of second matrix? Is it equal? I will say no. So matrix multiplication is not possible. So what I have to do? I have to transpose it. Means I have to shift 2 on this side and 3 on this side. So how can I do this? By transforming, by changing the configuration of this matrix. So how can we do this? Using transpose only, we can convert it. Okay. So let's implement the transpose now. Okay. Let's implement transpose now. So let me create one shell here. So I'm transposing this B matrix. Okay. So how can I do this? So see tf dot transpose. I just shown you how can we do transpose. So transpose, you have to pass your B there. And one more thing, you have to store it inside somewhere. So transpose underscore B, I'm creating one more variable here, transpose B. So if I will mention here transpose B, I will get the transposed value, and see the shape get changed. 3 comma 2 converted to 2 comma 3, and now this 2 comma 2 is able to multiply with this 2 comma 3 value, because this matrix column is equal to this matrix row. Okay. Now the most important part is second policy is, what should be the shape if I will multiply these two value? Because I know this this two matrix now get multiplied together, because the column is equal to row. But what should be the shape? What should be the matrix shape we will get? So I also thought about it. So the first value of the first matrix and the last value of the second matrix will be the shape after multiplication of these two matrices. Okay. So let's see, is it true or not? So let me clean this first of all. Okay. And I'm creating one more shell here. So I'm simply passing tf dot matmul, and I have to pass a comma. Now this time transpose B, because I just did transformation of B, right? So I have to mention transpose B, right? And if I will hit shift enter, I will get multiplied value. See, we are getting multiplied value. So this is the importance of transpose to do matrix multiplication, okay? And see the shape 2 comma 3. I already mentioned here 2 comma 3 as well. See on the screen. This is 2 comma 3 and this is the shape of after multiplication we are getting. So this is what I'm talking about, okay? Keep this thing in mind. Matrix multiplication is very much important in a TensorFlow or in a what you can say machine learning, deep learning. It is very much important, guys. So try to get such kind of basic knowledge of mathematics, because you guys always thought about it like we are calculating sine theta, but what is the use of sine theta, right? I want to tell you, sine theta is also important here, okay? Because you guys have to calculate similarity between two objects, and in that case you have to calculate sine theta cos theta, all right? So this is very much important, okay? I'm telling you, you will start remembering, okay? So this is used at this place, right? So such kind of thing happened, okay? So I would recommend you to go through at least your basic 10th mathematics book, okay, or 12th mathematics book. So that would be really helpful to you guys, all right? Hope you guys like this video then, and please share with your friend, family, and your colleagues in school, in college. So it will be a great help for me. Thank you guys. Thank you very much.